expect that we solve?
No.
You're not gonna make it that hard.
Okay,
No,
good.
no.
You're gonna make it easy numbers.
For the test, we still back to our mechanics material, the things.
So we're not gonna use eigen
No.
vectors and
Nothing
values
beyond that. No.
But here, my intention is,
for us to know.
yeah, you have to, hopefully you can pick this away with you.
Yeah.
Okay, so, okay, now we back to our equation using equation 1. So, let me use equation 1. So use equation 1. So the first one is for the first one. For sigma equal to 26.2, then what we have is we introduce the sigma into here, 5 minus 26.2 and 10, 8, 10, 7 minus 26.2, 12, 8, 12, 6 minus 26.2. And then L1, L2, L3 equal to 0, 0, 0. We simply introduce sigma into the template of this equation, then we have the things. And one features of the eigenvalue problems is, you can see in theory here we have 3 equations, 3 unknowns.
Oh, and then you solve for the...
We solve for the, so in theory we have 3 equations, 3 unknowns. We suppose we can solve for L1, L2, L3. But I can tell you, you wouldn't be able to solve for the numbers of the L1, L2, L3. Because among the 3 equations, they are dependent. Only 2 independent equations among the 3 equations. You know what I mean? Okay, so that means this is the essence of the eigenvalue problems.
So this is why we use MATLAB. So we don't have to.
No, you can solve for this by hand, but at most you can solve for its relation. For example, you take L1 as the scale, then you can find out L2 is how much portion of the L1, L3 is how much portion of the L1.
So they're all related to
They're related to a certain scale. At most you can solve for this. You wouldn't be able to solve for the number. But that is what we
So
do.
you're saying like in terms of,
Yeah.
like you just put everything in terms of L1?
Yes.
Okay.
So let me show you one, and you will see this quickly. So in this way, because here these are 3 dependent linear equations. Okay, so at most we can solve for, we can only solve for the relations among L1, L2, and L3. And for example, L1, L2, L3 will be equal to 0.51 and 0.631 and 0.579 and times alpha. Alpha is a certain constant. We don't know. We don't know, but at least this gives us the ratio between the 3 scales. So that means we have solved for the first one. So in terms of our notation, the first principal stresses will be equal to 26.2. And in which direction? In this direction, for example, this is 0.51 and 0.631 and then 0.579.
Wait, really quick. So for the... Wait, I thought it was like you could solve it in terms...
Yes. So, for example, in terms of 1 or in terms of certain coefficient.
Oh, so you can solve for the coefficient or you
Yeah.
solve like
Yeah.
everything in terms of L1?
Yeah.
Okay.
Yes. Okay. So in this way, because we don't know the number of the alpha, this cannot be solved unless we are given further information. But that is what we need, because in here in terms of the direction n, we don't care about the magnitude of these n vectors, but as long as its orientation is fixed, it's fine.
This is also if we're not given L1, 2, and 3, right?
No.
No?
No. For the principal directions, here we're going to solve, yeah, we solve for this one.
Never mind.
So basically, this is our n. This is our n vectors, and again, here for this
But that's the
expression,
principle, yeah.
the n is not normalized yet, but that's okay. But that's okay. As long as we have a direction to point into, whether it's a unit vector or not, it really doesn't matter. Okay? So this is for sigma, this one, and we can repeat. So we have three eigenvalues. So for sigma equal to minus 2.37. So now we're going to solve for this one. The same thing, you plug into that equation here, 5, 7, 6, minus,
Plus.
yeah, it should be plus, right?
But yeah, you just repeat the same thing then.
You
for
repeat the
everything
same
else.
thing, repeat the same thing. So here we will be able to solve for L1, L2, L3, and equal to, for example, here is 0.815 and minus 0.153, and then minus 0.560, and this one is say beta. Okay.
Wait, are these going to be the same angles that you use later? Like, are you using alpha, beta, gamma specifically so that way you can use like the cosine?
No, the
you're-
alpha
this
is,
unrelated, right? I'm
yeah,
just- that's what I'm
unrelated,
using.
unrelated. So why not I take?
Sorry.
Okay, whatever.
You can leave it as alpha.
C1. Okay. So this is our vector. For example, say you can designate this is for the first principal direction, this is second principal directions. And this is the second principal stress, this is the first principal stress, etc. Okay, so that is pretty much enough for no, for this topic.